Hello and welcome to Highway Design. This is one of my favorite problems, how to describe the length of the queue due to a speed reduction. If you ever work in construction, when you have a lane closure, stuff like that, this type of knowledge comes in really handy. So let's understand the problem. We have a two-way highway, traffic going this way and traffic going that way. In this highway, they told us the volume is 1,500 vehicles per hour. Take a look at what I have on a board too. What do you mean by the volume? I mean, at if I put a marker right here, 1,500 vehicles passes this marker in 1 hour. That's what the volume is, and they call it a flow, they call it a queue, okay? So that's what it is right now, before anything happening. And then we have a density of 20 vehicles per mile. What does density mean? Let me just bring this up for you. Density means basically if I have a section of roadway and I got a bunch of cars right here, all bumper to bumper, okay? Bumper to bumper. And they call this a density, like how many cars you can fit in this one section of a highway. Could be 1 mile, could be 100 feet, could be 1,000 feet, doesn't matter. We're gonna name it as per mile. So how many vehicles you can put in 1,000 feet. If it's all backed up like this, like Boston, which I drive every day, they call that a jam density, like bumper to bumper. And if it's like I-95 in New Hampshire when I drive, if everybody's going 70, 80 miles an hour, that's basically really the best, and you might get a 20 or 30 vehicle in 1 mile because they're all going so fast. And if you shut the highway down and nobody in it, obviously is zero. So that's what density means. So this section of highway, before anything happened, the flow is 1,500 vehicles and the density is 25 vehicles per mile. Then, on a local road, there's a dump truck coming in, and it wants to haul this load, go all the way here, this dump truck, and it wants to keep going this way and back in here to dump his load. But the problem is this dump truck, when it comes in here, it's only can go 10 miles an hour. These people, we don't know how fast they go, and all we know is the flow is 1,500 vehicles, and density is 25 vehicles per mile, because we've got one of those reader or one of those things in the pavement that can tell us that. So now, when this truck comes in the highway here, and everybody, the whole platoon of vehicle, backs up behind him, they have to go slow because they have to go his speed. They can't pass because this side is also busy. So they got stuck, and I'm sure you all been through that situation. They get stuck behind this vehicle. And then our reader over here, it says, wait a minute, density went up to 100 vehicles per mile. There's more car in a section of roadway. And your flow has reduced to 1,000 vehicles per hour. Now the question asks, calculate how many vehicles will be in a platoon by the time the truck leaves the highway. So by the time the trucks get here, how many vehicles will be stuck behind them? Pretty cool. All right, let's get to work. So one of the first things we're going to do, we're going to complete the shockwave velocity. What I mean by shockwave velocity is, so when you're going fast on the highway and there's something slow you down, that created a shockwave behind you, the shockwave velocity. Because now you're going 70 miles an hour and you're reduced to a 50, 40, or 30, and that creates a shockwave. Let's find that shockwave velocity. And that's given by this equation right here. I'm just going to write it down. Shockwave velocity, VU, depending which book you're looking for. Our textbook, which I have the reference down there, have this equation for it. It's Q2 minus Q1 divided by K2 minus K1. So that's equal. Our second Q is going to be 1,000 minus Q1, which was 1,500. And density was 100 vehicle minus 25. That gives us minus 6.7 miles per hour. That means it created a shock wave about negative 6.7 miles per hour going the other way. Now, you got to remember, as these coming in and create a shock wave, everybody has no choice but I got to follow this big dump truck. And the dump truck is going this way. And it's going to go that way. And it's going 10 miles per hour. This marker is no good. So now we have that. And that's going to create a growth rate backward. Let's calculate that. And we're going to say, okay, the growth rate because this is going 10 miles an hour, it's going to be minus this other number, minus 6.7, and that gives us a 16.7 mile per hour, and it's going to grow based on that. It's just a rate. Next thing I want to find out, the truck's going to get here, and it's going to leave here. That's 2.5 miles. How long it's going to be in this area? Well, it's easy to calculate. It's going 10 miles an hour, and it's 2.5 miles. So I'm going to come and say, okay, let me put it right here, divided here. Time, truck, on 2.5 mile section. So that's equal. So the time this truck's going to be right here, it's going to be 2.5 miles divided by, it's going 10 miles per hour. It's about quarter hour, 0.25 hour, or 15 minutes. So take 15. Imagine you're driving 70 miles an hour and you have to stick behind something going at 10 miles an hour for 15 minutes. I've been there and it's painful. And I'm sure you all have been there. So anyway. So we're going to find out what is the length of the line of a car or platoon car behind them by the time the trucks get here. How long this is going to back up. We have a 15 minute, 0.25. And the growth rate was 16.7 miles per hour. That gives us a 4.2 mile. A lot of time you get on the highway, you look on the other side, you say, what's traffic is backed up? This is why it caused the backup. 4 mile backup is a lot. We want to know how many vehicles really stuck in here in this traffic. Well, the marker we have in a roadway, not those like wire they got in a roadway that you can go over, or they have a reader, it can read it from above. It tells us that the density turned out to be 100 vehicles per mile. So we want to know what is the number of the vehicle. In traffic behind the truck. It's equal, we got K came out to be 100 vehicle per mile, and it's a 4.2 mile. So these two cancel each other out. It's going to come out to 420 vehicle. This is pretty cool. This is basically how we usually on a highway, when you do simple calculations like this, we can calculate the flow rate, the Q backup, and stuff like that. Hope this was a short, nice video. You liked it. If you like it, give it a thumbs up.